Do you want to load images onto your website, but keep getting CORS issues? In this video, I'm going to show you how to build an API to resolve those CORS issues. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best AWS and serverless developer that you can be. In this video, we're going to be creating a brand new API repo that has the sole purpose of creating a proxy so that we can do requests from our website, but change the CORS headers so we can load assets from other websites. This is really good for quite a few different reasons. For example, if a customer is uploading an image by passing in a URL, then you can make sure that you're able to access that image and it's not blocked by anything like CORS. So first we're going to jump into the browser and see what happens when we try and access a CORS restricted image, and then see how we can build our endpoint and our API so that we can get around this. Before we jump into the video, I just want to say that Complete Coding is actually looking to hire a new serverless solution architect. So if you're interested, make sure you stick around to the end of the video where I'll give you some more details. Before we start looking at the code, I just want to say that I had some audio issues with the recording. So I'm now dubbing over this video, so if my mouth doesn't sync up with what I'm saying, that is exactly why. So to demonstrate this, what I've done is I've opened up my website, the Complete Coding website, and in the DevTools, I've opened up Fetch, which allows me to query an API as if I'm on this page. This means that if there are issues, such as CORS, it will show in this request. I've got an image from the JD Sports website, and if I try and make this request, I get a pending promise, and then I get an error saying that the CompleteCoding.io website has been blocked by CORS as the access control allow origin header has blocked this URL. This obviously isn't great, as it means if I was using this image inside one of my blog posts, then what would happen is the user would get a blocked image placeholder and the user wouldn't be able to see the content of that image. That's not good, and sometimes you want to be able to use images from other sites. To fix this, we need to jump into our code, create a new repo and an API that allows us to proxy these requests, but adding the headers that we need. So the first thing that we need to do is open up a terminal and set up a new repo for ourselves. I've already set up serverless and a profile for this, and if you haven't done this before, I've got a link in the description below which will link to a video on how to set up all of this. So what we're going to do is in our terminal, we're going to write SLS create --template, as we want to use a template to create the boilerplate for this repo. The template we're using is AWS-Node.js -TypeScript, and we're also going to pass in a path, and the path defines the folder, so I'm going to call this CORS API. This is going to create the CORS API repo and populate that with the boilerplate for TypeScript. Now that's happened, if I open up that new repo and find the CORS API, we can have a look at what this template has generated us. In that folder, we want to first run npm install and this will just install all the dependencies whilst we have a look through the template and what is generated. The main thing is the serverless.ts file, and this is where everything is defined and how our whole package is going to be built. Here we have some custom Webpack things, as well as the provider, which actually defines our runtime of Node.js 14, and some environment variables. Finally, at the bottom, we declare our functions object, and that contains a function of hello, which we've imported from functions/hello. We can see that in functions/hello, and here we can define how our function wants to exist. We have our handler from the hello folder, and then we are triggering this lambda with an event from HTTP with a method of post and the path of hello. We're going to be changing this a little bit, and the first thing we're going to do is change the folder from hello to CORS Proxy. We're going to say yes to all of the imports, as if we go down to our serverless.ts, we're now importing hello from functions/CORS Proxy. We're also going to find all of the hellos and change those to CORS Proxy, as that accurately describes the function that we're actually going to be creating. In our CORS Proxy folder, inside our index.ts, we're now going to change our handler, point to handler.main, but inside our event, we want to change the API Gateway configuration, get rid of the request schema, and delete it from our imports, and we can actually delete it from the folder. We also want to change the method to get, and our path we want to change to CORS-proxy. If we save all of that, we now have our new definition for our function and our events. So now anytime we do a GET request to CORS Proxy, it's going to call our handler.ts and the main function inside that. If we look inside our handler.ts, there is a lot of boilerplate here. This boilerplate has been set up to provide you a lot of functionality to do quite a few different things, but our API is relatively simple, so what I'm going to do is select everything and delete it and start from scratch. The first thing we need to do is create our main function, and that's because we are calling the handler file and calling the main function inside there, so that's what we need to have. So we have const main equals an async function, and that takes an event. That event needs to be an API Gateway event, which should come from AWS Lambda. Now we've defined our main function, we can add the logic into here. The way this is going to work is inside our API call, we're going to have a query string containing the URL. With that URL, we're going to get that image and whatever needs to be proxied and return that to the caller, so it can be used by the front-end application. So if we say const query string equals event.queryString parameters, we need to then try and get the URL off there. So inside a try catch, just if there's an error, then we can handle into that catch section, but we'll deal with that in a second. In our try, what we need to do is first get the image, so const image equals fetch image, and we're going to pass into this a parameter of query string dot URL, and that is going to be the URL part of the query string that is calling the API. Now we need to make the fetch API in just a second. Once we've fetched the image, we need to do another step to work out what MIME type the image is. So const type equals image type, and we're going to call that function passing in the image. This image type is a function, and we're importing that function from an npm package. So we need to install that by, in our terminal, running npm install -- save, and the npm package we're installing is image type, and the second one is called Axios. Axios is what we're going to be using to request our image. So that has now downloaded all of our packages. So now we can import our image type like this. So import image type and import that from image type. We're also going to import Axios from Axios. Now we need to define our fetch image. So below our main function, we're going to say that const fetch image equals a function which takes an image URL, and that is going to be a string type, if I can type that correctly. Once we've fetched this image, all we need to do is return Axios.get, and we're going to be getting the image URL. But we also need to pass in some option config. Inside there, we need to say the response type is going to be array buffer. Once we've got the image, we need to do a little bit of extra work. So then we're going to add a .then, where we're going to take that response from the Axios.get, and we're going to return buffer.from, and then we're going to pass in response.data and turn this data into base 64. So what we're doing is we're getting the image. Once we've got the image from Axios, we're turning the data of that response, which is the content of the image, turning it into the buffer and changing it from base 64. Now that we've got that, we now have our image, which is a promise of a buffer. So we have to first await this fetch image so that now this image is actually the buffer. This then gets passed into our image type, which will calculate our type. Now that we have the type and the image, we can generate our response. So we're going to return an object, and with API Gateway, you always need to return a specific format of data, and that is going to have a status code of 200. It's going to have some headers, and these headers are first a content dash type with a capital T, and the reason we needed to get the type earlier is because the content type needs to be set to the image. It could be a JPEG, or it could be a PNG or a GIF or a different type of image. So here the content type is going to be type.mime. We're also going to have access dash control dash allow dash methods, and this is going to be a star for now, as we want to be able to update these. I've just duplicated that previous line, so we can create our third one because we need access control allow origin. So this we want to also have star, which basically allows any of the origins to request this API. This is kind of the whole point of this API, to avoid the CORS restrictions from the original image. If you're having this specifically built for one URL that you have, you could change this to a URL that you own. In my case, it could be completecoding.io in this case, and then if someone else tries to call this API, they would not be able to access the images through this. So now that we've got all the headers, we need to attach the body. In our case, the body is going to be image.toString, and we're going to be stringifying this to base 64 because that is what API Gateway needs it to be. We also need to say is base 64 encoded is true. So this is just telling API Gateway that this body is base 64, so it knows how to handle that. Now this is what's going to happen if everything goes well, where we get the image, we get the type, and return the image. But this time we're going to override the headers, saying that the origin that can query this image is star. If there is an error though, for any reason, then we need to add some extra logic. Here we're going to first console.error, the error message, because it's always nice to know what the error was. Then we're going to return something relatively similar to the original object, so status code. This time we're going to be setting it to a 500, as this is the unexpected error. We're also going to add a body, and in this case it's just going to be a string of unable to return the image. So if we save all of that, we can now define our main function. So at the moment we have defined the function, but we haven't actually exported it. Inside our index.ts, we are expecting to call a handler file and call the main function, which needs to be exported. So back in our handler.ts, we need to add export and save that. So now we're exporting it so it can be imported into our function definition. The final thing that we need to do is some configuration around API Gateway. Because we're configuring this as base 64, we need to go back into our serverless.ts file, scroll all the way down to our provider. Inside our provider, there is a section for API Gateway, and we need to add one extra parameter here, which will allow us to successfully turn this API response into binary data. And that is a field called binary media types. And we want to set this to an array of */*. If we save all of our files, we are actually ready to deploy. But I first want to talk about this binary media types. This is just telling API Gateway that the request may respond with a binary data and that it needs to be formatted properly. If you don't do this, then you get back almost the right image, but it doesn't contain the image data properly, which is honestly pretty useless. The one disadvantage of adding this is that it changes all of the objects that you also receive on posts or put requests, and that becomes a 64 stringified version of the JSON string you would normally expect to receive in the body. This honestly is a bit frustrating, as it means that if you have this added to your API gateway, then you have to add extra logic to decode the event body before you JSON parse it. So I would recommend not using this inside a API repo that has other endpoints. For example, if you have a full suite of APIs with updates, gets, deletes, and all those kind of things, I would recommend creating this API proxy in its own repo and deployment, so you can keep this binary media types configuration out of your main API, which will keep that nice and simple. Now that we've talked about that, we can jump into our terminal and run SLS deploy. What this is going to do is it's going to take all of this configuration, including the function definition and the function content, package it all up and deploy it to your AWS account. This does take a little while, so I'll get back to you when that is done. Now that has done, we can look in our terminal at the result of our serverless deployment. We've created our CORS API service in US East 1, and the important thing for us is that we have this new URL here, which is the endpoint we just created. I'm going to copy that endpoint and head back to our browser. Before, we were doing this request where we were getting the URL image directly, and that was giving us a CORS error. With our new API, what we can do is if we, at the start of this URL, paste in our new URL. So this is our request to the CORS proxy, but we need to pass in the image URL as a query string, so $URL equals. So now we're saying that we're calling CORS proxy API, passing the URL string of the image, and if I hit enter for that, it's going to append and then return a 200 response. And this doesn't seem to be any CORS issues at all. If we want to test this out, we can also copy this whole URL, open up a new tab and paste that in, and we can see that we have that full image. So one thing you need to do is make sure that you test the full image on a new tab, because if you haven't added that binary media types, then you won't see a CORS issue, but you won't see any issues. You'll see a grey box that you'll see will have a message, but it won't show the image. So that's one thing I definitely advise doing before you deploy this into something like a production account to make sure that everything works as expected. In this video, we have seen how CORS can stop us accessing images. We've then seen how we can set up our own repo and our API to be able to change the headers that we get from our API request and pass those back to our front end. When we tested this out in our own browser, we're able to see that we actually got a 200 response, which shows that we were able to get the image that originally had some CORS issues on it. As I mentioned at the start of this video, Complete Coding is looking to hire a new serverless solution architect. If you want to come and work with me, with our clients, helping them adopt and make the most of serverless, then in the description below will be a link to our job description. And yeah, get in touch and you could end up working with me and helping our clients with serverless projects. If you've learned something new in this video, make sure to smash that like button as it really helps out the channel. And if you haven't done already, make sure to subscribe down here and turn on the bell notification as well so you get notified next time I upload a YouTube video. Thank you, and I'll see you next week.